It's an indisputable fact that seatbelts save lives. When a car comes to a sudden stop, the seatbelt prevents you from hurtling forward. It spreads the stopping force across the sturdier parts of your body, namely your ribcage and pelvis. You can sit safely in your seats as we bring you this one. Before production can begin, the factory has to adjust the seatbelt design to fit a specific model of car, to make sure that the belt's path is clear and there's enough room for rotating parts to move. Robots assemble most of the components. This plastic disc, containing a spring and a weight, is part of the locking mechanism. It's what stops the seatbelt straps, called the webbing, from lengthening when you jerk forward due to a sudden stop. The locking mechanism goes into the seatbelt's retractor mechanism, the component that lets the webbing extend and retract. The webbing will wind onto this aluminium spool in the retractor, a rewind spring keeping it taut. Sudden deceleration will cause this silver ball to trigger the locking mechanism. This will stop the spool from rotating and lock the webbing. The next robot assembles the pre-tensioner mechanism. This pulls the webbing back sharply, tightening any slack. It kicks in only in the event of a crash. The sudden deceleration on impact triggers sensors which signal the airbag control module to send an electrical charge to the pre-tensioner. This charge sets off a tiny explosion that takes up the slack in the belt. The explosive device, called the micro gas generator, or MGG, is installed. After the inside of its aluminium cylinder is lubricated with grease, a piston is inserted into the MGG. The MGG contains a chemical called nitrocellulose. The electrical charge coming from the airbag control module ignites this chemical, causing a tiny gas explosion. That generates pressure within the cylinder, driving the piston upwards at high speed. This triggers a gear that winds the retractor spool backwards, taking up any slack in the webbing. After capping off the micro gas generator's housing, a robot transfers the completed pre-tensioner mechanism to the retractor's frame. Then, it screws on a steel cover plate to hold the pre-tensioner in place. The rewind spring is installed onto the spool of the retractor mechanism. This spring is what provides resistance when the user pulls out the webbing to buckle up. When it's unbuckled, it rotates the spool to rewind the webbing. The thicker the spring and the more coils, the greater the tension, and therefore the faster and smoother the belt retracts. But the greater the tension, the less comfortable the seatbelt is on the body. The webbing is made of woven polyester fibre. This machine sews a loop for the pin that'll anchor the webbing to the spool. The pin is made of either plastic or steel. Now the end is threaded through a machine that automatically winds the webbing onto the retractor spool. The machine checks the overall belt length to make sure it conforms to the client's specifications. At this factory, every single seatbelt component has to pass through a thorough quality control check. Here, a machine checks a key safety feature, a lever and ratchet mechanism that prevents the webbing from extending after a child's seat has been fitted. Finally, all the seatbelt parts are loaded into a jig, a holding device that arranges them in the proper configuration. The webbing is fed through the shoulder loop from which the belt hangs, and through the tongue plate, the part that clicks into the buckle. Both these components are made of steel for strength, with plastic coverings matching the car interior. The last step is to sew the anchor to finish off the other end of the webbing. Every seatbelt design goes through extensive testing before going into production. This machine assesses how much pull the webbing and retractor can withstand before breaking. This machine tests the webbing's durability. And after all that, you know you're in for a safe ride. Just make sure you buckle up each time.